All right, welcome back. We are in the middle of lesson 28. This is lesson 28, part 2. So in the part 1 video, we learned about some different formulas. I would encourage you to, if you haven't already, maybe have like an index card or one page in your notebook where you have all the formulas in one place, so you can start to refer to them and recognize when to use them and when not to use them. All right, so let's take a look at some multi-step examples. So these problems, oftentimes the instructions will tell you to factor completely. If you may remember from a previous lesson, that's often a clue that there's more than one type of factoring going on. There's more than one formula or more than one process that we need to do. Okay, so also you won't necessarily be told which formula to use, which is part of the challenge, right? So let's take a look at number 1. All right, so first thing I'm noticing is, these numbers look kind of big, and maybe you'll notice that there's a y squared, but it's not the first term. So the problem is 108y minus 12y squared minus 243. Let's start by rearranging our terms and putting them in descending order. So let's rewrite it so that that squared term goes first. So I'm going to rewrite negative 12y squared and then plus 108y minus 243. Okay, so now what do we do? Let's see, our first term starts with a negative, so let's plan on factoring out something that's negative, and let's hope there's a GCF here. Let's see, 12, 108, 243. It might take a little bit of kind of trying different numbers. Let's see, 2 is not going to work because 2 doesn't go into 243. Let's see if 3 works. I'm just going to quickly try dividing each term by 3 on my calculator. 108 divided by 3 is 36. 243 divided by 3 is 81. 12 divided by 3 is 4. Yeah, let's try 3. So I think our GCF, we're going to take out negative 3. All right, so we're taking out a negative because our leading term is negative. Okay, so when that's the case, we want to factor out a negative, and let's take out a 3. So negative 3 is coming outside. All right, now what's left over? Each of these terms will get divided by negative 3. So this first term is now positive 4y squared. 108 divided by negative 3, that's negative 36y. Negative 243 divided by negative 3, that's now positive 81. All right, so we have this negative 3 on the outside. 4y squared minus 36y plus 81 is the trinomial that's left over. We've just been working on perfect squares, so let's see if we can use that to our advantage. Is this a perfect square trinomial? Let's find out. Here's how we can be sure of that. Let's check that the first term, 4y squared, that's equal to something squared, that's equal to 2y squared. The last term, 81, that's equal to 9 squared. We just need to check that middle term. And so I'm just writing off to the side. A perfect square trinomial might look like a squared minus 2ab plus b squared. So we need to check on that 2ab in the middle. So is 36y equal to 2ab? So 2 times 2y times 9. And again, the 2y and the 9 just come from the a and the b term on either end. If I multiply those together, yes, 2 times 2y is 4y times 9 is 36y. So yes, it looks like we're all set up to use our formula, which just says this is equal to a minus b squared when I want to factor this. So a minus b, that would be 2y minus 9, parentheses, squared. And don't forget that negative 3 that we took out before. That's still here. That's still part of my answer. So our final answer is negative 3, parentheses, 2y minus 9, close parentheses, squared. All right, so we recognized that we had a perfect square trinomial. If you did not recognize that, that's okay. You could also just factor it using other methods, such as the AC method or trial and error. So back up here to this step where we had the 4y squared minus 36y plus 81. Maybe you would have set up two parentheses, 2y times 2y, that's 4y squared. And then maybe you would do 9 times 9, that's 81. And recognize that you need the signs to be you need the signs to be the same, sorry, to equal positive 81. So maybe minus 9, minus 9. And then you would check 2y minus 9 times 2y minus 9, that's 4y squared, minus 18y, minus another 18y, and then plus 81. The minus 18y and minus 18y combined together, that equals minus 36y, which is what we had as our middle term. So if that method is more familiar to you and what you'd rather use, that's fine. But if you can recognize that it's a perfect square trinomial, that's fine too. All right, so yeah, another way to write the answer, you could write -3 and then parentheses 2y minus 9, and then another parentheses 2y minus 9, rather than writing -3 and then parentheses 2y minus 9 squared. Either one of those is fine. All right, good. Next one, number 2. This problem has 4 terms. We haven't seen that in a little bit. So this will be a good review of how do we factor something with 4 terms. All right, let's take a look. So it's w to the 3rd minus 81w squared minus 4w plus 324. So just a reminder, when you have 4 terms, the method that you should try to use is grouping. Okay, factoring by grouping. So there's no GCF, there's no greatest common factor with all 4 of these terms. So let's break them into groups. Okay, so again, because there's 4 terms, we'll split them into 2 groups of 2. Then within each of those groups, we'll be able to take out a GCF. So with the first group, w to the 3rd minus 81w squared. The GCF there is w squared. And then what we're left with is just going to be w minus 81. Now let's move on to the second group, our last 2 terms, minus 4w plus 324. Okay, 324 is obviously a big number. Let's check and see if 4 goes into it, and it does. Also notice that there's a negative here, so let's factor out -4. And then we'll be left with w. And then 324 divided by -4 is going to be -81. Okay. So we have w squared parentheses w minus 81, and then -4 parentheses w minus 81. The w minus 81, that's your common factor, so let's rewrite that, w minus 81 parentheses, and then our next factor will be w squared minus 4. This is normally when the problem is over. However, it's not over because w squared minus 4, that is a difference of squares. That's that kind of recent formula that we learned, the a squared minus b squared equals a plus b, a minus b. So w squared minus 4 can be broken down into, oops, w plus 2, w minus 2. So our full final answer is w minus 81 in parentheses, and then w plus 2 in parentheses, and w minus 2 in parentheses. So there's 3 factors in our full final answer. And if you notice, we did not do anything to try to factor w minus 81 because that w didn't have a 2 exponent on it. So that was done. W minus 81 can't be factored anymore. But the w squared minus 4, that was the difference of squares. So this is a classic example of factoring completely. Look at the 2 different methods we had to use. We had to use factoring by grouping, and then we used the difference of squares. We had to do both. All right. 2 down, 2 to go in this last section. Okay, number 3, b to the 4th minus 32b squared plus 256. Oh boy, okay, so what do we do? All right, I'm hoping for a GCF. There is no GCF here. I can't do GCF. Okay, can we do grouping? No, because there's only 3 terms. All right, is this a perfect squared trinomial? You might not recognize it, but this number 256 is equal to 16 squared. That is a perfect square. On your scientific calculator, you should have a way to take the square root. Okay, so this is a way you can figure out if a number is a perfect square. Use the square root function. So on my calculator, I have to do second, and then I have this x squared key on my calculator. There's a little square root above it, and then 256. Your calculator might be different, but that's one way you can figure out if a number is a perfect square. Okay, so that's a good sign. Let's see. If 256 is a perfect square and equal to 16 squared, how is that going to help? Let's find out. All right. All right, so I'm trying to figure out, is our trinomial in this form? Okay, so 256, that's a perfect square, that's 16 squared. b to the 4th, that's a perfect square because the exponent is even, so it's equal to b squared squared. And then finally our middle term, I need to check if that fits that pattern of 2ab, 2b squared, oops, and then 16. So 2 times b squared times 16, yeah, that is 32b squared. Okay, so it looks like we're all set to use this formula. So when we factor it, it would be a minus b squared. So b squared minus 16 squared. All right, so let's write that out. B squared minus 16 squared. All right, so are we done? Let's take a look at what's in the parentheses here. That can be factored more. So this is the part of the problem where I'm trying to decide where to go from here because there's more than one way. Let's see. I'm deciding whether to write it twice or not. I think I will leave it as it is. But let's see how we can simplify or factor the b squared minus 16. So one way to write our answer would be b squared minus 16 all in parentheses squared. But that's not fully factored because the b squared minus 16, that can be factored more. That's a difference of squares. That's your a squared minus b squared pattern. A plus b, a minus b. So I can write inside these larger parentheses, I can now write smaller parentheses, b plus 4, b minus 4. So this looks a little strange with these layers of parentheses. So I have parentheses and then other parentheses, b plus 4, close parentheses, new parentheses, b minus 4, close parentheses, close the big parentheses, squared. This is one way to write the answer. Another way to write it is b plus 4 squared and then b minus 4 squared. That's another way to write it. As I have done a couple times in this lesson, let me take us over to our whiteboard and let's see if there's maybe a different, possibly better way to do this one. All right, so we had b to the 4th minus 32b squared plus 256. Okay, maybe you just didn't know that 256 was a perfect square. So you just set up your parentheses and we're just gonna do trial and error, no problem. So if I look at my first two terms, they need to multiply to b to the 4th. B squared times b squared is b to the 4th, great. Now I need my last two terms to multiply to 256. And eventually I'll need my outside and inside terms to add up to negative 32. So I could do minus 16 and then minus 16. Negative 16 times negative 16 is positive 256. When I distribute, I would get b to the fourth and then minus 16b squared minus another 16b squared plus 256. Those middle terms add up to that minus 32b squared. Okay, so maybe this is how you would factor it. Okay, fine. Each of these b squared minus 16s gets broken down more into b plus 4, b minus 4. And then again, b plus 4, b minus 4. So this is a much longer way of writing the final answer. B plus 4, b minus 4, b plus 4, b minus 4. I hope you can see that, see how there's two of each, right? So the b plus 4 shows up twice, so I could write b plus 4 squared. And then the b minus 4 also shows up twice, so I could write b minus 4 squared. Many ways to write the final answer. All right. All of these ways I've shown you are equally correct. Okay, so use the one that makes the most sense to you. Okay, and if you can't already tell, these are some of the harder problems. They'll probably show up maybe near the end of your homework as you're working your way through this lesson. All right, back we go. That was number 3 in this set of multi-step problems. Let's look at number 4. X to the 6th minus 729. Okay. The 6th, okay, what are we going to do here? Well, we've seen some formulas with perfect squares. We've also seen formulas with perfect cubes. 6, it's a multiple of 2 and it's a multiple of 3. So which should we do? Should we treat it as a perfect square or a perfect cube? Okay, there's a couple ways to answer that. One way to answer it is you could do either one. However, speaking from experience, it will be much, much, much easier if we start by treating this as a difference of squares. Okay, so I know that this 6 is a multiple of 3, but let's focus on the fact that it's a multiple of 2. So let's treat this as something squared. So it's going to be x to the 3rd squared. Okay, so wait, hang on a second. Don't we need to we need to figure out, is 729 a perfect square? I mean, it wasn't on our list because we ran out of space, but it is. So I'm going to go to my calculator and I'll do that process that I just told you before. You might have a shift key. My calculator has a second key. I'm going to do second, and then I have an x squared button with a little square root above it, and then 729. Because I don't know the square root of 729, or at least I didn't before I did this problem ahead of time. And look at that. The square root of 729 is 27. All right, fine. So I'm rewriting this problem. Here was the original problem, okay? So x to the 6th minus 729. I'm rewriting it as a difference of squares. X to the 6th is rewritten as x to the 3rd squared minus 729 is rewritten as 27 squared. Difference of squares. Here's what we mean by that. That's going to be a plus b, a minus b. Okay, so based on this setup here, it's going to be x to the 3rd plus 27, and then x to the 3rd minus 27. Okay, are we done? Can you guess? No, we're not done. There's more. Okay, now what we need to do is look at each of these individual factors and see if we can do anything else to them. And we can. Hopefully you've started to recognize the number 27 at this point. That is a perfect cube. So here's what we get to do next. We have x cubed plus 27 times x cubed minus 27. Each one will use one of our cube formulas. Okay, so the first one, x cubed plus 27, this will use the a cubed plus b cubed formula. A is x, b is 3. Okay, so let's write out our answer. The original formula starts with a plus b. So we're going to write x plus 3 in parentheses. Next, in the formula is a squared minus ab plus b squared. So we're going to write x squared minus x times 3 is 3x plus, instead of b squared, we'll write 3 squared, which is 9. Okay, so just a little note that I'm adding a was replaced with x, and then b was replaced with 3. Okay, that's half of the answer. Okay, now, so what we just did is we took x cubed plus 27 and we broke it down using the sum of cubes formula. Now, the second half of our answer, x cubed minus 27, we will use the a cubed minus b cubed formula. So still, a is x, b is 3. It's just that now we're going to use the formula with those different signs, right? So instead of a plus b, now we're starting with a minus b, and then a squared plus ab plus b squared. All right, whoops, go back. All right, so instead of a minus b, we're going to write x minus 3, new parentheses. Instead of a squared, we will write x squared plus a times b, that's x times 3 or 3x, plus 3 squared is 9. Okay, so there you go. We did it. That was I think that's the longest problem. Starts off so short though, doesn't it? X to the 6 minus 729. So we started off by breaking it down into perfect squares. X to the third squared minus 27 squared became x to the third plus 27, x to the third minus 27. Then each of those was factored, recognizing each one as a perfect cube. The first one was the sum of cubes, x cubed plus 27, and then the second one was a difference of cubes, x cubed minus 27. And one more time, our final answer was x plus 3, x squared, oops, I made an error. I hope I said it right, but I think I wrote it wrong before. I had written x to the third, it should be x squared. So starting again, here's our final answer. Ready? So x plus 3, x squared minus 3x plus 9, x minus 3, x squared plus 3x plus 9. And we're done. Okay, good. So there you go. All right, so that's the end of lesson 28, special factoring formulas. Okay. There's so much in these lessons. Okay, so here is where we are. You've pretty much learned all the different types of factoring so far. But here's what's coming next. Now, our next lesson is pretty much a review lesson, which we could probably all use. So when we move on to lesson 29 coming up, we really are going to just kind of do more problems like this where we put everything all together. And it's really going to be more of a mixed bag of just, it'll say factor, and we'll just do more practice figuring out what does that mean anymore? What does factoring mean? Does it mean take out the GCF? Does it mean grouping? Does it mean using a formula? So we'll practice kind of organizing all the different methods we've learned so far. That's what's coming next. And we'll kind of take it from there. All right, so good job making it to the end of another video, and just keep up the good work. Thank you.